Here we are in the constellation Andromeda. This star is Beta Andromedae. The light by which we see this star has spent 75 years traversing interstellar space on its journey to the Earth. In the unlikely event that Beta Andromedae blew itself up a week ago Tuesday, we will not know of it for another 75 years, as this interesting information, traveling at the speed of light, crosses the enormous interstellar distances. When the light we see from this star set out on its long interstellar voyage, the young Albert Einstein, working as a Swiss patent clerk, had just published his epical special theory of relativity here on Earth. We see that space and time are intertwined. We cannot look out into space without looking back into time. The speed of light is very fast, but space is very empty, and the stars are very far apart. In fact, the distances that we've been talking about up to now are very small by the usual astronomical standards. In fact, the distance from the Earth to the center of the Milky Way galaxy is 30,000 light years. From our galaxy to the nearest spiral galaxy like our own, called M31, is 2 million light years. When the light we see today from M31 left on its journey for Earth, there were no human beings on the Earth, although our ancestors were nicely evolving and very rapidly to our present form. There are much greater distances in astronomy. The distance from the Earth to the most distant quasars is 8 or 10 billion light years. We see them as they were before the Earth itself accumulated, before the Milky Way galaxy was formed. The fastest space vehicles ever launched by the human species are the Voyager spacecraft. They are traveling so fast that it's only 10,000 times slower than the speed of light. The Voyager spacecraft will take 40,000 years to go the distance to the nearest stars, and they're not even headed towards the nearest stars. But is there a method by which we could travel in a conveniently short time to the stars? Can we travel close to the speed of light? And what's magic about the speed of light? Can't we travel faster than that? It turns out that there is something very strange about the speed of light, something that provides the key to our understanding of time and space. If the world is to be understood, if we are to avoid logical paradoxes when traveling at high speeds, then there are certain rules which must be obeyed. Einstein called these rules the special theory of relativity. Light from a moving object travels at the same speed, no matter whether the object is at rest or in motion. Thou shalt not add my speed to the speed of light. Also, no material object can travel at or beyond the speed of light. There's nothing in physics that prevents you from traveling as close to the speed of light as you like. 99.9% the speed of light is just fine. But no matter how hard you try, you can never gain that last decimal point. For the world to be logically consistent, there must be a cosmic speed limit.
The most bizarre aspect of traveling near the speed of light is that time slows down. All clocks, mechanical and biological, tick more slowly near the speed of light. But stationary clocks tick at their usual rate. If we travel close to light speed, we age more slowly than those we left behind.
Today, we have preliminary designs of ships which will take people to the stars. They are constructed in Earth orbit, and from there, they venture on their great interstellar journeys. One of them is called Project Orion. It utilizes nuclear weapons, hydrogen bombs, against an inertial plate each explosion providing a kind of putt-putt, a vast nuclear motorboat in space. Orion seems entirely practical and was under serious development in the United States until the signing of the international treaty forbidding nuclear weapons explosions in space. Orion might go 10% the speed of light. So a trip to Alpha Centauri, 4.5 light years away, would take 45 years, less than a human lifetime. Such ships could not travel close enough to the speed of light for the time-slowing effects of special relativity to become important. It does not seem likely that such ships would be built before the middle of the 21st century, although we could build an Orion starship now. For voyages beyond the nearest stars, something must be added. Perhaps they could be used as multi-generation ships, so those arriving would be the remote descendants of those who had originally set out centuries before. Or perhaps some safe means of human hibernation might be found, so that the space travelers might be frozen and then thawed out when they arrive at the destination centuries later. But fast interstellar spaceflight, approaching the speed of light, is much more difficult. That's an objective not for 100 years, but for 1,000 or for 10,000. But it also is possible. A kind of interstellar ramjet has been proposed, which scoops up the hydrogen atoms which float between the stars, accelerates them into an engine, and spits them out the back. For most of the trip, the velocity would be very close to the speed of light, and time would slow down enormously. By how much? Barnard's star could be reached by such a ship in 8 years ship time. The center of the Milky Way galaxy in 21 years. The Andromeda galaxy in 28 years. Of course, the people left behind on the Earth would see things somewhat differently. Instead of 21 years to the center of the galaxy, they would measure it as 30,000 years. When we got back, very few of our friends would be around to greet us. In principle, such a journey, mounting the decimal points closer and closer to the speed of light, would even permit us to circumnavigate the known universe in 56 years ship time. We would return tens of billions of years in the far future, with the Earth a charred cinder and the sun dead. Relativistic spaceflight makes the universe accessible to advanced civilizations, but only to those who go on the journey, not to those who stay home. These designs are probably further from the actual interstellar spacecraft of the future than Leonardo's models are from the supersonic transports of the present. But if we do not destroy ourselves, I believe that we will one day venture to the stars. When our solar system is all explored, the planets of other stars will beckon.